Okay, thanks, Professor Cheng, for your kind introduction, and thanks for the ISEG organization committee. Okay, my topic today is effects of cement on the workability of fresh sand, cement, and bentonite mixtures for cut-off wall construction using the two-phase method. This work was done in Nanyang Technological University with Professor Yi. Okay, my presentation consists of 4 parts. First, I will introduce the research background. As we know, the seepage cut wall with a low permeability is usually constructed in soil, especially in sand layers, to prevent groundwater seepage through for various civil engineerings like dam, dig. Earlier, soil bentonite cut wall had been widely used as insular vertical barriers to prevent groundwater flow. But now, recently, soil cement bentonite cut wall has been used more frequently because it has high strength with the addition of cement slurries. The trace remixing and cutting deep wall (TRD) method is able to create high homogeneous soil cement bentonite cut walls compared to other insular mixing methods like the deep mixing methods. In general, for the TRD cut wall, it can be conducted using the one-phase method or the two-phase method, as shown in this picture. In the left figure, it's a two-phase TRD method. For the two-phase method, as shown in the figure, the natural soils is first cut and mixed with the cutting floor in the first phase, and the sand bentonite mixture is remixed with the hydraulic mixture in the second phase. In the first phase, bentonite slurry is typically bentonite slurries is typically selected as the cutting fluid, and the cement slurries is usually selected as a hydraulic band. For the one-phase method, the natural soil is cut and mixed with the two slurries simultaneously. For the cut walls instruction in a relatively deep mess or hard soil, the construction performed to execute in the two-phase method. Moreover, previous studies were designed for soil cement bentonite cut walls using the one-phase method. There is less knowledge on the two-phase cut wall. So the workability of the wall materials is critical for the homogeneity and the mechanical property of the cut walls, including the UCS and the permeability. And the workability of cut wall materials is commonly quantified using the flowability and the bleeding. In general, a good workability requires a high flowability and a lower bleeding rate. Okay, let's move to the second part of my presentation, which is about the workability of sand-bentonite. It corresponds to the first stage of the two-phase TRT method. In our study, 2 types of sand and 2 types of bentonite was selected, and the particle size distribution curve that was shown in this picture. And the two sands have different granulometries. We named fine sand and coarse sand in our study. And the 2 bentonites was categorized as sodium bentonite and calcium bentonite. Based on their liquid limit and strain index results, we can find that sodium bentonite has a much better water retention capacity and straining potential. Okay, to prepare our sand bentonite mixture, the dry sand and the bentonite was firstly mixed in a mixture for 5 minutes, and clear water was added and mixed for another 5 minutes. This process is similar to the first phase of the cut wall construction. Then the workability of the fresh sand-bentonite mixture was immediately tested for flowability test and the bleeding test. The flowability test was using the flow table, using flow table method. The flow table method using standard flow mode and standard flow mode and flow spread diameter with the method. Apparently, large flow spread diameter means the higher flowability. On the other hand, bleeding test using 1,000 millimeters cylinder, and the volume of bleeding water was recorded at 3 hours dating, and the bleeding ratio was defined as the ratio between the volume bleeding water and the initial volume of the water in the cylinder. Okay, next is our results. First, the flowability result is provided. The desired flow spread diameter for construction proposed is between 150 and 230 millimeters, as shown in your pictures. From the next picture, we can see that the diameter for the pure fine sand is below the 150 millimeters. It means the addition of bentonite is required to obtain the workability of flowability. Moreover, the flowability spread diameter saw a linear increase with the increase in the water to sand ratio for the both 2 sand and 2 type of bentonite. And compared these 2 figures, the flow spread diameter is insensitive to the sand grinding. Okay, here is the bleeding result. In general, the acceptable bleeding water should be less than 3. And it was expected that the bleeding water for both sand was increased by increasing the water to sand ratio. We can also find that the bentonite has the significant effect on bleeding of the sand-bentonite mixture, depending the bentonite content and the bentonite type. Moreover, it's clear that the sodium bentonite is more effective to control the bleeding water than the calcium bentonite. So we can conclude that the sodium bentonite is better than calcium bentonite in the condition of workability in the first stage. Okay, the third part is about the workability of sand, cement, and bentonite, correspond to the second stage of the TRT method. Okay, 5 sand bentonite mixture was first selected to investigate the effects of cement slurries. A similar flowability of selected sand mixture is selected, and no bleeding water was observed for these 5 workable mixtures. To prepare sand cement bentonite mixture, the cement slurry was added to the fresh sand bentonite mixture and mixed for 5 minutes. This process is correspond to the second phase of the cut wall construction, and this fresh mixture was immediately subject to the flowability and bleeding test. From the flowability test result, we can find that both so first both the effect of water to cement ratio and the cement content, these two factors were considered in our studies. Based on the left picture results, calcium bentonite based mixture is more sensitive to the change the water content than the sodium bentonite based mixtures with is engagement with the results in the first stage.
Professor Chen, 3 minutes left.
Okay, thank you. Interesting. A significant difference in the flowability for these two type of bentonite mixtures, and as shown in the right finger of the flow diameter of mixture increased as the cement content. To better clarify the effect of cement thread, the left finger compared the change of flowability caused by addition dry cement and cement slurries. We can find that based on the dry cement result, we can find opposite change in the flowability is we can find for the two types of bentonite. For sodium bentonite mixture, the flowability increased, but for the calcium bentonite, the mixture flowability is decreased. This formula can be clearly seen from the photo of mixtures after the flow table testing. Here is the bleeding result. The bleeding result show that the bleeding water tend to increase as the water to cement ratio and the cement content for both two bentonite types. By comparison, the bleeding of sodium bentonite mixtures was higher than calcium bentonite mixtures with the same bentonite content, because in the first place for sodium bentonite mixtures, a higher water to sand ratio is selected. Additionally, addition of cement slurry occurs more increase in the flowability and the bleeding for sodium bentonite mixtures. Okay, here is about the bentonite cement interaction. Previous studies have demonstrated that cement can chemically affect the hydromechanical behaviors of the cement, behavior of the bentonite, sorry, and the original sodium and in bentonite interlayers was exchanged with the released calcium ions from the cement slurries, result calcium bentonite, and the diffused double layers of bentonite particle was reduced. For select cement bentonite mixture, we conduct the XRD test. The result confirmed the cation exchange between the bentonite and the cement, and this reaction lead to the significant reduction in the work retention capacity and the swelling potential of sodium bentonite. And we can also find that this reaction is worked very quickly. Okay, last part is the two main conclusions in our studies. Addition of cement would cause significant increase in the flowability and the bleeding for sodium bentonite based mixtures in the first phase because of the chemical reaction between cement and sodium bentonite, and the XRD results identified this cation exchange between them. Okay, finally, this study was under the support of MOE Singapore and the Chinese Postdoctoral Council. Okay, that's all. Thanks for attention.